So then, Joe, we're in that wonderful position where the customer behind us has decided to have an electrical vehicle and they're going to have the ZAPI EV charging point installed. However, it's really crucial that before the installation occurs that we do the pre-installation site survey. What sort of information are we going to be required for that survey?
Well, we're introducing quite a heavy new load onto the existing system, so we want to make sure that the system is capable of dealing with that. It'd be much the same if we were looking at installing, say, a new electric shower.
Yeah.
However, there's some key points that we also need to look at that relate directly to the fact that we're installing an EV charge point. So we're going to look at the regular things. We're going to look at the cable route, and we're going to look at the existing equipment. We're going to have a look at the old consumer unit and see what spare ways there are, what RCD protection there is, that kind of thing. But there's some critical information that we need for this as well. And some of this information will need to be transmitted possibly to the DNO.
Oh, yeah.
So this is quite a big deal. So the place where we're going to find an awful lot of that information is round at the origin. So I think we're going to have a look at that now.
Let's have a look. So we'll move around to the intake position of this installation, Joe, and there's some information we're going to need to gather here as part of our site survey, as well as informing the DNO. Can we get away when we're installing an EV charging point with not letting our local DNO know, Joe?
The simple answer is no, you can't. If you're installing an EV charge point, you must let the DNO know. And the reason for that is obvious. There's going to be more and more properties over the coming years getting EV charge points installed. There's going to be a bigger demand placed on the existing infrastructure, which we're pretty confident can handle it. We're not worried about that. But really, it's part of your social responsibility to help the DNO, the electricity suppliers, know where there's going to be greater demand and where there's going to be peaks in demand. So it's very important that we take our social responsibility on board and let the DNO know if we're installing it.
Demand being the word there. So the maximum demand and diversity of this installation is the critical point.
Yeah.
As soon as we exceed 60 amps with our calculation, we must inform them prior to actually installing the EV charging point, Joe. If we find that that maximum demand and diversity calculation is under 60 amps, and we've done a few, Joe, how easy is it to keep them under 60 amps?
It's almost impossible. In fairness, this property is not an electrically hungry property. We've got gas central heating and hot water. There's no electric shower, there's no electric hob. So you can imagine it's not a very power hungry property. However, when we start doing the calculations and we think about installing our EV charge point, we very quickly go above that 60 amp up to somewhere around 70.
Okay, so that means we must inform them before installing it.
Absolutely.
If you're in a fortunate position where your maximum demand calculation becomes under 60 amps, you've got 28 days after install in order to notify your DNO.
Absolutely.
However, Amendment 1 to BS 7671 introduces an important change to the maximum demand and diversity calculation. If the EV charge point includes a load curtailment device that can be set to limit the maximum demand on the property, then this can be taken into account when doing your maximum demand and diversity calculation. This means a device that measures the total current flowing into the property, and if this total current goes above 60 amps, the power going to the electric vehicle is automatically reduced. The MyEnergy ZAPI includes this device, so as long as the maximum demand you calculate for the property is below 60 amps before the ZAPI is installed, there's no need to get approval from the DNO before you do the installation. Of course, you've also got to make sure that this limit device is set correctly when you do the installation, and you should also contact the DNO if you have any doubts about the authorised supply capacity. Let's go back and have a look at the supply cable coming into this property.
So we're looking at the information that we've got in here. So as an electrician, we're coming to this point here, and I notice that the supply cable coming in from the supply authorities is coming underground into the bottom of our cutout.
Yeah.
Okay. Any issues with other ways the cable could come in, Joe?
Yeah, in sort of certain towns and certain rural properties, maybe we've got a row of houses.
Yeah.
It was common practice to bring one cable, bring it to the first property, and then to loop from there to the next property, and so on and so forth. And of course, all the properties would have their own meters and their own electrical installations. However, again, let's think through the situation. Every house on that row gets an EV charge point and plugs their cars in. You're going to very quickly start overloading that first cable that comes to the first property, and even possibly several of the subsequent cables. So if we come across a property where we think we've got a looped supply, what do we need to do, guys?
Stop. You've got to let your DNO know, and you can't at that stage install your EV charging point. There'll be some other stuff that needs to go on in the background before you're given permission to install an EV charging point. So that's really crucial and really critical. We haven't got that issue here, Joe. Supply cable comes into the bottom. We notice it's got a PME sticker here. We know it's a TNCS earthing arrangement. Does that throw up any issues for us?
Well, we're installing a ZAPI charger, so we can sit back and relax with a TNCS system. But it's very much worth thinking about this fact that even if you come across a TNS system and you're installing an EV charge point, you still have to treat it as though it were TNCS, because you can only treat it as a TNS system if you can guarantee that that system will never be converted into a TNCS system at some point in the future. How are you going to guarantee that it'll never become TNCS?
Just rub that magic ball and hope for some information to come back. You can't. So, of course, you're going to have to presume that would also be a TNCS earthing arrangement.
Absolutely.
But if we're installing a Zappi EV charging point, it doesn't matter for us, does it?
No, it's electrode.
No, and it's the information that's required for our paperwork and obviously for the DNO. We come into a 100 amp cutout fuse. Can we presume that's a 100 amp cutout fuse, Joe?
We can assume it is indeed a 100 amp cutout fuse, but again, we come back to that 60 amp value. We can't assume it's 100 amps for maximum demand purposes. So obviously we'd want to make sure that we treated the tail situation, the cable coming out of here, as though it's a 100 amp fuse, but from a demand point of view, we want to think about it as being a 60 amp fuse, because that really is what the DNO originally intended to allow for properties as a maximum demand value.
Hence, once you go over 60 amps, you'll notify them before the install to the DNO. That makes logical sense as well. We've got the usual arrangement. We've got a 25mm squared double insulated meter tails, our 16mm squared earthing conductor, and it may be a case, Joe, that when we go in and look at the install, actually we're going to have to install another consumer unit in there.
Possibly.
So we might have to break into the tails, maybe put some Henley blocks in there. Can you talk us through the safety procedure for that as well, please?
Well, obviously, we don't want to go pulling the fuse if we can possibly avoid it, because that really is the property of the DNO. In this situation, we're quite fortunate because we've actually got an isolating switch within the meter that we can use to isolate the tails. However, if you come across a situation where you don't have that, and there's a lot of them about, you need to inform the DNO and they will come out and install a double pole switch for you. So they'll actually come out and put that in so that you can then safely isolate the installation, split the tails if you need to, don't get prosecuted for pulling the fuse, and don't get prosecuted for electrocuting someone by doing the terrible risk of working live. So that's just an important little point to think about.
I think now we swing around and look at the consumer unit. Let's make some other judgment calls based on the installation that we've already got, Joe.
Let's go.
So we stepped inside and to look at the consumer unit now as part of the site survey. Standard arrangement, main double pole switch and several circuits here. We've got 2 blank ways, and then we've got a split board. We've got an AC 30 milliamp RCD protecting several circuits within the house, and we've also got a blank on the RCD side as well. So it looks as if we've covered all bases, Joe. So okay to go on one of those for the circuit?
Well, let's kind of work from left to right. Here are options. We could install it into the spare way that we've got here. However, we've got to think about the RCD requirement for our EV charge point. We need to have RCD protection because obviously we've got a socket outdoors kind of situation, so we need to have RCD protection for that. We may need RCD protection for the supply cable going from the consumer unit out to the charge point. So let's just work through that logically now. The Zappi charger has RCD technology built into the charge point.
It does.
So the fact that it's built into the charge point, Gary, what potential problem could start to happen if we've got this RCD protecting the RCD that is in our Zappi charge point?
Well, a couple of things there. First of all, selectivity. So you're going to have 2 RCDs rated at 30 milliamps, and there's no guarantee which one will operate, and that can cause inconvenience. So we've got a problem with selectivity. We also said this is an AC type of RCD, and we know that introducing EV charging points can cause issues with a current which is DC appearing in the line and neutral conductor, and that can confuse AC RCD. So there's 2 issues there: lack of selectivity and a chance of confusing or stunning an AC RCD. So it's not deemed good practice that we install our EV charging point off from this point here, Joe. That means I've got another 2 options. I've got 2 options here. Can I use one of those, Joe?
Well, we've got our non-RCD protected side there, so potentially, again, we could use that. Now, the thing we've got to get around here now is we've got to think, how are we going to install our cable without RCD protection? We've got the RCD protection in the Zappi protecting the socket outlet, but we don't have RCD protection protecting the cable. So let's try and think about, how do we install the cable without an RCD requirement? So what would be our options for that?
So we're requiring to maybe surface clip twin and CPC cable would remove the need for the RCD, or we install it in an earth metallic sheath, possibly steel or armoured, in order to feed the charging point itself. Both of those instances would remove the need for an RCD.
So for the purposes of this installation and this instructional video, Gary, how are we going to go about wiring up our Zappi 2 charger?
We're not going to come off the non-RCD side of the consumer unit. By the time I'd sourced the appropriate size Hager breaker, it might have been easier to install an additional consumer unit. For the purposes of this presentation, I want to show you how to install a additional consumer unit, the tails, the Henley blocks, etc. Also gives us an opportunity if we want to introduce surge protection into the new consumer unit. So that's the consumer unit looked at. Now we need to verify and confirm the bonding to gas and water in this installation are in place. I'm going to nip out and look for the water.
I'm going to go and find the gas. That was pretty easy. So Gary, I had the monumental task of finding the gas bond. There it is.
Yeah.
Okay, so I've seen this green and yellow conductor coming onto this bonding clamp, coming onto this gas pipe. Have I therefore verified the gas bond connection?
You found the gas bond connection. We verify it through measurement, Joe. We're going to need to measure the resistance at this point here, and I always like to measure the resistance actually onto the pipe itself in order to verify it. I've been under the sink. I found the water bond as well. I've only found it. We also need to measure it to verify it's in position.
That's very important we do that.
So I've had the pleasure of coming inside, Joe, just to warm up a little bit. It's been cold today.
Absolutely, and the customer has very kindly allowed us the use of their dining room table in order to do the next stage of this, which is the all-important maximum demand and diversity calculations. So let's get stuck into that.
So we're going to be using the maximum demand and diversity from Appendix H of the on-site guide in association with this document here, Joe. What book's this?
So this is the Electrical Installation Design Guide published by the IET.
Okay. A
really, really excellent book for if you're doing anything to do with electrical calculations. I think that's a must-have. It's really, really helpful.
There's some different examples in here. We're actually going to be using example 2 in order to work out the maximum demand of this installation.
Absolutely. Now, maximum demand is one of those things, isn't it, where it's down to your engineering judgment. There's lots of different ways we could calculate it. Every installation will actually be slightly different in terms of maximum demand. And it's one of those things where you need to make a call on what method you're going to use, what you think the maximum demand will be. But in this case, we think that this is appropriate for this kind of installation, this kind of property. We think that the information in the on-site guide and inside this book are both really, really appropriate.
With that in mind, we've got to start off by first of all identifying the sizes of circuit breakers in circuit, Joe.
Fantastic.
So let's do that. Let's just move this to one side so you can probably get this a little bit clearer into view. So we've got now with our consumer with an added circuit, we've got a 32 amp overcurrent protection device for the EV charging point, Joe.
Right, so we've got the new circuit, which is a 32 amp EV charging point. That's great.
We've got 2 ring final circuits fused at 32 amp as well, probably upstairs and downstairs, Joe.
Yeah, so we've got a 32 amp socket circuit. Okay, and we've got another 32 amp feeding sockets as well.
Okay. We've got a 16 amp device feeding the cooker circuit. We talked about it earlier. It's just a fan assisted cooker. There is no electric hob or anything else.
Okay, hence it's a slightly smaller breaker than we might normally come across. Yep.
Yeah, we've got that, and we've now got 3 6 amp devices. One of those devices is actually for the smoke detector circuit, Joe.
Okay, so we've got 6 amp smoke.
Yeah, I think later on we'll probably put that down as not applicable. The current being drawn by one smoke detector circuit.
It's hardly going to draw anything at all, is it?
And 2 lighting circuits also fused at 6 amp. I'd imagine it's upstairs and downstairs.
Okay, so we've got 6 amp, we'll call that lights. Let's go lights down. And then we've got 6 amps for lights up. Okay.
So the method we're going to use, Joe, requires us to pick the circuit that we believe to be the maximum demand or the highest demanded circuit out of these and call that 100% of the actual load.
Okay.
So we could choose any of the 3 32 amp devices. However,
well, for my money, when are these ever going to be fully loaded at 32 amps? There's a small possibility maybe for a fraction of a period in the kitchen, maybe, whatever that's on, if you've got a couple of 3 appliances on. However, for my money, it's got to be the EV circuit. Now, we know that the Zappi is very clever and it can manage the amount of current that it allows to flow through to your vehicle. However, there will be times when that is the maximum amount that's being drawn. So I think I agree, we'll call that the 100% largest circuit. Yeah?
We could delve in a little deeper. We could actually do the 7 kilowatts divided by 230 to get the actual current being drawn by it and call that the 100%, but it's a fraction over 30 amps, Joe. I don't see any reason to do that. I think if we called it the 32 amps of the breaker size and call that one 100%, that's our starting point.
Absolutely.
It means now that we can take 40% of the remainder. I think we make the smoke detector not applicable.
Okay.
We do not need, Joe, to apply any further diversity calculations to the cooker. However, we could, if it was a full electric cooker with electric hob, we could follow the guidance in Appendix H to work out the actual demand of that. We don't need to, so again, we've got the 16 amps there. I think we can apply a maximum demand and diversity calculation to the lighting circuits, Joe, by working out how many lighting points we have in the installation.
Okay.
Each of those lighting points will be classed as how many watts?
So each lighting point will be 100 watts.
It will be. And if we add those up, the number of 100 watts and divide it by the supply voltage, we can